So did the sum of the price of the 3 shirts exceed $60? This is what we want to see if we can answer. So option 1 tells us the price of the most expensive shirt exceeded $30. So we have 3 shirts. If the most expensive shirt was 30 plus, then we don't know if the price exceeded $60. We don't have enough info. What if this is a $5 shirt and another $5 shirt? That wouldn't exceed $60. What's option 2? It says the price of the least expensive shirt was $20. Okay, if the least expensive shirt was $20, then the others have to be more than 20. So let's say 21 and 22. This exceeds $60. So our answer for this question would be answer B, where option 2 is enough information for us to determine the answer. Next question. What is the total number of coins that Abby and Allie have? Okay, option 1, or statement 1, Abby has 50% more coins than Allie. Okay, 1 alone definitely won't be enough information, as, you know, Allie could have 6 and Abby could have 9, or Allie could have 8 and Abby could have 12. You know, these are different values. What's statement 2 say? The total number of coins Abby and Allie have is between 21 and 28. Okay, so here we're told that the total is between these two values. So it could be 22, 23, 24, 25, 26, or 27. 27. Okay, so this alone is not enough information, but maybe if we put the two together, we do have enough information. Okay, so notice in these two examples I drew up, if Allie has 6, here I'll label them Allie and Abby. If Allie has 6 and Abby has 9, that would be a total of 15. So that's not quite there. If Allie has 8 and Abby has 12, that would be a total of 20. So that's not quite in the mix. But notice that this is trending up by 5. So if Allie had 10 and Abby would have to have 15, and that would give us a total of 25. So that would check. And then if we went a little bit more and said 12 and 18, that would go all the way up to 30, and that would be too much. So the two statements together does give us enough information to determine that they have a total of 25 coins. So the answer must be choice C. If there's any question as to why I was jumping by 2s with Allie, it's simply because you can't have half a coin. If I said Allie has 13 coins, then Abby would have to have 6.5 more, making 19.5. And you can't have half a coin, so that's why we were jumping by 2s there. Okay. Next question. It is given that jazz and blues recordings accounted for 6% of the $840 million revenue of recordings in country Y in 2000. Determine the revenue from the sales of jazz and blues recordings in 1998. So we want to know the revenue from the sales of jazz and blues recordings in 1998. We were given some info about jazz and blues recordings in the year 2000. So what's our first statement says? It says, this indicates that jazz and blues recordings accounted for 5% of the revenue for sales of recordings in country Y in 1998. So statement 1 tells us that jazz and blues was 5% of the revenue, but it doesn't tell us what the revenue was. Therefore, statement 1 is not enough information. Statement 2 says the revenue of sales from the sales of jazz and blues recordings in country Y increased by 40% from 1998 to 2000. Well, the question tells us the revenue in the year 2000. It tells us that it was 840 million. And statement 2 tells us that it increased by 40% from 1998 to the year 2000. Therefore, we would be able to determine the amount of revenue in the year 1998. So our answer for this question is going to be choice B. Statement 2 is enough information. Now remember, for these questions, you don't have to solve the problem. You just have to determine if you have enough information in order to solve the problem. There's a small distinction there. So we don't need to actually calculate the revenue for 1998. We just need to be comfortable with the fact that we have enough information to do so. And in this case, we are. All right, next question. If x is a positive integer, what is the value of the square root of x plus 24 minus the square root of x? Okay, statement 1 says the square root of x is an integer. Okay, so that's all fine and dandy. We have the square root of x plus 24 minus the square root of x. If the square root of x is an integer, that's fantastic, but we still don't know what the square root of x plus 24 is, so we don't have enough information. What about statement 2? What does it tell us? Statement 2 says the square root of x plus 24 is an integer. Okay, well similarly, that's all fantastic. If we say that this is an integer, that's great. But we still don't know what the square root of x is, so we wouldn't be able to calculate what this full equation is. We wouldn't be able to determine this value. Okay, so lastly, what if we put them together? Okay, if we put statement 1 and 2 together, then we are going under the assumption that both the square root of x is an integer and the square root of x plus 24 is an integer. So let's play around with some numbers in order to determine what the value could be. Well, I would first notice that, hey, what if the square root of x, what if x was just equal to 1? What if we had x equal to 1? Well, then we would have the square root of 1 plus 24 minus the square root of 1. And the square root of 1 plus 24 is, of course, the square root of 25 minus the square root of 1, which is just 5 minus 1, which is 4. So this is great, but you need to look for more than just one example. Is there any other number we could plug in for x that would allow both sides to be an integer? And what I'm noticing is yes. What if we let x equal 25? Well, then we would have 25 plus 24, and we'd have 25 here. And 25 plus 24 is 49. And 49 is, of course, 7 squared. So in this case, cleaning this up some, we would have 7 minus 5, and we would have an output of 2, not 4. Therefore, we do not have enough information to determine the value of this expression, even with both statements. Therefore, our answer is choice E, not enough information. Fantastic. Next question. A group consisting of several families visited an amusement park where the price of admission is 5,550 won for adults and 4,800 won for each child. Because there were at least 10 people in the group, each person paid 10% less than the standard admission price. How many children were in the group? Okay, so this question is definitely a systems of equations question where we know the number of children plus adults must be greater than or equal to 10. And we also know that each child pays 4,800 won. So 4,800 times child plus 5,550 times adult is going to equal our total. We don't know our total. And we're also told that because there's more than 10 people in the group, each person is going to pay 10% less. So we can go ahead and wrap this and put a 0.9 on the outside because each child and each adult is actually going to pay 10% less than the listed value. Okay, with that, what are our statements? Statement 1, the total price paid for the adults in the group was 29,700 won. Okay, so we know that 0.9 times the 5550 times the adult price, the number of adults rather, is going to equal a total of 29,700. Now, is this enough information to determine how many kids were in the group? And it's not enough information. Here we could certainly solve for A. We could solve for A and say A equals some number, but we're told that the number of children plus adults is just greater than 10. So whatever value we'll find for A, as long as there's enough kids to be more than 10, then it's a moot point. Like, what if there's 10 kids already or 11 kids already? Then the number of adults doesn't really matter. So statement 1 is not enough information. What about statement 2? It says the total admission fees for the children in the group was 4,860 won, more than the total of the admission fees paid by the adults. Okay, so let's use a second color for statement 2. So we're told that our children, so the children paid 90% of 4,800 won, and we're told that the children in the group was 4,860 more than the adults. So this is going to equal 90% of what the adults paid minus 4,860. Or actually plus 4,860 because the children paid 4,860 more. Okay. So here again, if I'm just looking at what I just wrote down here in orange and what I have up top, we do not have enough information to solve. Because again, we don't know the total amount paid and we don't know how many people were going in general. We don't know how many adults and kids went. If we knew either of those, then we would have enough information, but we still don't have enough information here. However, whenever we group in statement 1, well, statement 1 allows us to solve for the number of adults. And with that difference, we would then be able to solve for the children using this relationship. Therefore, our answer for this problem is going to be choice C. Whenever we combine the two statements, we do have enough information. What is the ratio of the average height of students in class X to the average height of students in class Y? Okay, so we have class X and class Y, and we want to know the ratio of the average height between the two classes. So statement 1 tells us the average height of the students in class X is 120 centimeters. But we have no information about class Y, so of course statement 1 is not going to be enough information. What about statement 2? In statement 2, we're told the average height of the students in class X and class Y combined is 126 centimeters. Okay, so looking at statement 2, well, we know that the average height of X and Y combined is 126. So the average of class X could be 126 and class Y could be 126. Or class X could be 125 and class Y could be 127. And we now have a different range. So we still don't know exactly what the values could be for each of these classes. So statement 2 also is not enough information. Let's try to combine the two and determine if we will then have enough information. So we're told by statement 1 that class X has 120 average height. And in statement 2, we're told that the average height of the students in class X and Y combined is 126 centimeters. So you would naturally think that the class Y is a pretty tall class with an average height of 132 centimeters. Therefore, the range is 12. And you'd probably be very tempted to say both statements together is the answer, choice C. However, I'm saying it like this because there's still something we need to mention. And that's that we were never told how many students were in each class. You see, if we were told that student X or class X and class Y have the same number of students, if we were told that, hey, class X has 10 students and class Y has 10 students, then this would be fantastic. However, what would happen? Would there be something different if, let's say, class Y had 20 students? Well, if class Y had 20 students, then we could change this average to 129. We could change this to 129, just lower it by a little bit, and we would still have an average of 126 centimeters between the two classes, but we would have a different range, okay? And so because we're not told how many students are in each class, we actually don't have enough information to solve this problem. And so this is going to be choice E with not enough information. So with these problems, look out for little tricks like this. We could have noticed right away, oh, we don't know how many students are in each class, so really no matter what they give us, we're not going to have enough information to solve this problem. However, it's very tricky in that you think you have enough information at first glance, but you really don't. We really have to determine how many students are in each class in order to answer this question to its full extent. Next problem. Is the positive two-digit integer n less than 40? So is n less than 40? This is our question. What does statement 1 tell us? It says the units digit of n is 6 more than the tens digit. Okay, so we are going to divide n up into the tens place and the ones place, and we want it to be less than 40. And if the ones digit is 6 more than the tens, what are some possibilities? Well, we could have 3 and 9, or we could have 28, 2 and 8, or we could have 1 and 7. Could we have, well, 4 and then 6 more than 4 is 10, and 10 won't fit in the ones digit. And so this alone, our only possibilities from statement 1 are 39, 28, or 17. So statement 1 is enough information for us to determine that n is less than 40. What about statement 2? What about statement 2? N is 4 less than 4 times the units digit. Okay. N is 4 less than 4 times the units digit. So 4 times the units digit minus 4. Well, what's the largest possible units digit? The largest possible units digit is 9. So if we plugged 9 in to our units digit, then we would have n is equal to 4 times 9 minus 4, which is 32. And 32 is less than 40. Therefore, statement 2 is enough information for us to determine that n is less than 40. Therefore, our answer is D. Both statements individually are enough information for us to determine the answer to this question. Fantastic. If k is an integer such that 56 is less than k, which is less than 66, what is the value of k? Our first statement says that if k were divided by 2, the remainder would be 1. Okay, so let's quickly write out the possible values for k. The possible values for k include 57, 58, 59, 60, 61, 62, 63, 64, and 65. It does not include 56, and it does not include 66. Okay, it's exclusive, not included. Okay, statement 1 again says if k were divided by 2, the remainder would be 1. So that in essence tells me that k is an odd number, because an odd number divided by 2 has a remainder of 1. However, statement 1 doesn't narrow it down any more than that, so I still have some questions up in the air. And so statement 1 is not enough information. So what does statement 2 say? Statement 2 says that if k plus 1 were divided by 3, the remainder would be 0. Okay, so let's look for all of our multiples of 3. Of course, we have 57, we have 60, we have 63, and 66 is a multiple of 3. I'm highlighting 66 even though it's not part of our list, because we're told that if k plus 1 were divided by 3, the remainder would be 0. So really, we're looking at 65. 65 plus 1 is 66, and 66 divided by 3 has a remainder of 0. So we're looking at all the numbers directly to the left of our multiples of 3. So we have 59, 62, and 65. So again, we have multiple values, so statement 2 is not enough information. And if we're looking at both statement 1 and statement 2, well, both 59 and 65 are circled or marked twice. Therefore, we don't have enough information even with both statements. Therefore, our answer is going to be choice E, with not enough information. Last year, if Arturo spent a total of $12,000 on his mortgage payments, real estate taxes, and home insurance, how much did he spend on his real estate taxes? So we want to know his real estate taxes. We know that he spent a total of $12,000 on the mortgage, the real estate, and the home insurance. And we want to find R out specifically. Okay, let's look at statement 1. Last year, the total amount that Arturo spent on his real estate taxes and home insurance was 1/3 of the amount he spent on his mortgage payments. So here we have, 1/3 of our mortgage is equal to our real estate plus our home. Okay, so here, notice that we could group R and H together, and we could have we can change our equation to be 12k equals M plus 1/3 M, and we could solve for our mortgage payment. However, we're not looking for a mortgage payment, we're looking for our real estate taxes. So statement 1 is not enough information. If it was asking us about mortgage payments, it would be, but it's not. Now, what about statement 2? Statement 2 says last year the amount that Arturo spent on his real estate taxes was 20% of the total he spent on his mortgage and home insurance. It was 20% of the total from the mortgage and home insurance. So this is telling us that his rental was 20%, so 20 out of 100, 20% of his mortgage plus his home insurance. And here, well, now we can solve m plus h in terms of r. You know, we could do some maneuvering and we would have 12k equals m plus h. That's going to be 100 over 20 r, then plus another r. And here we could solve for our real estate taxes. Therefore, statement 2 alone is enough information, so our answer is going to be choice B. Next question. Is the number of members of Club X greater than the number of members in Club Y? So we have Club X and we have Club Y. So what does statement 1 tell us? Statement 1 tells us the members of Club X, 20% are also members of Club Y. So for Club X, let's say we had something like 10 members. Well, Club Y would have 20% from Club X, so that's 2 members right off the bat. But then it could have some random amount more. It could have 6 more, or it could have 60 more. We really don't know. So we don't have enough information to say whether Club X has more or less members. So statement 1 is not enough information. What about statement 2? Of the members of Club Y, 30% are also members of Club X. So here we can say something very similarly, whereas, okay, let's say we have 10 members from Club Y. Well, then Club X would have 3 members from Club Y, but the remaining members could be anything from 4 to 40. So we still don't know which side has more members. What if we tried to put the statements together? Okay, the statements are telling us that there's an overlap in membership. So let's draw like a little Venn diagram, okay? Here we have a circle. Oops. Here, I'll just duplicate this. Duplicate. Perfect. So we have some Venn diagram. We have Club X and Club Y. Let's call these values A, B, and C, where the overlap B is really what we need to focus in on. In statement 1, we're told that from Club X, 20% are also members of Club Y. So that tells us, our statement 1 tells us that our B value is going to be 20% or 1/5 of the members of A plus B. Okay, B equals 20% of all of Club X, which is A plus B. All right. From this, we can multiply it out. We can get that 5B is equal to A plus B. All right. What does statement 2 tell us? What does statement 2 tell us about B? Well, statement 2 tells us that of the members of Club Y, 30% are members of Club X. So we can say something very similar in that B is going to be equal to 30% or 3/10 of Club Y, which is just B plus C. And then we can, of course, solve or extrapolate to get that 10/3 of B is equal to B plus C. Now notice whenever we are comparing both of these, we have 5B equals A plus B, and we have 10/3 B equals B plus C. Because 5 is greater than 10/3, we can conclude that Club X does have more members. We can figure out that this A value must be bigger than this C value that's differentiating the two. the two clubs. Therefore, both statements together, we do have enough information to determine that the number of members of Club X is greater than the number of members in Club Y. So this answer is choice C. Each of the letters in the table above represent one of the numbers 1, 2, or 3, and each of the numbers occurs exactly once in each row and exactly once in each column. What is the value of R? Okay, this is a fun little Sodoku. So we have some box, we have RST, UV, X, Y, Z, and we're told that V plus Z. So we're told that here for our first statement, we know that V plus Z equals 6. And we know that each number can only occur one time in each row or column. So if V and Z added together equals 6, then that implies that both V and Z have the value of 3, as 3 plus 3 is 6, and each number or each letter can only be 1, 2, or 3. Okay? If V and Z are both 3, then let's mark out everything that shares a row or a column. Okay, R is left by itself, so R must also have a value of 3. So this statement 1 is enough information for us to determine the value of R. Now let's go on. Let's look at statement 2. What does statement 2 say? Statement 2 says S plus T plus U plus X equals 6. So S plus T plus U plus X equals 6. Okay, well, we have four variables that are all adding up to be 6. So notice that one of them, so notice that U and X are in the same column and S and T are in the same row. Okay, also notice that R is the meet in the middle point of the ST row and the UX column. Therefore, U must equal either S or T, and X must equal the other variable. If U is to S, then X is to T. And so, again, we will have enough information to determine that R must be the value of 3. So our answer is choice D. To go a little bit further with statement 2, so none of these values could be 3, because if you plugged in 3, then everything else would have to be 1, and you can't have two 1s in the same column, so that wouldn't work. So that means everything has to be either a 1 or a 2. So if T is a 1, then S must be a 2. And if U is a 1, then X must be a 2. And so the only thing left for R to be is a 3. Our answer is still option D, where both statements individually are enough information. Next problem. In planning for a trip, Joan estimated both the distance of the trip in miles and her average speed in miles per hour. She accurately divided her estimate distance and her estimated speed to obtain an estimate for the time in hours that the trip would take. Was her estimate within a half hour of the actual time that the trip took? So Joan did all the math right, but we want to know if her estimate was within half an hour of the actual time. So what does statement 1 say? It says Joan's estimate for her distance was within 5 miles of the actual distance. Okay, let's say the actual distance was 20 miles. Okay, that means her estimate was within 5 miles, so it could be anything from 15 to 25. However, we don't know how quickly she was traveling, right? What if she was traveling like 1 mile per hour, like she was just walking? Okay, then the difference between 15 and 20 or 20 and 25 miles is going to be way more than just half an hour. It's going to be a 5-hour difference. So we don't have enough information here. What about statement 2? We're told that Joan's estimate for her average speed was 10 miles per hour of her actual average speed. Okay, well, let's say she was going 20 miles per hour. Okay, she was going 20 miles per hour, and so her estimate was within 10 miles per hour, so she could be going as slow as 10 or as fast as 30. Now we're ignoring what's in orange, of course, right now. We're not even looking over there. We're just looking at these speeds. So she could be going anywhere from 10 to 30, and we want to know if the total time she took, or we want to know if her estimate for what she thought she would take was within a half hour. Well, we don't know without knowing the distance, right? We don't know how far she traveled. Okay, so going 10 miles an hour versus 20 miles an hour, that's a big difference. You know, if she was traveling over a long distance, that will definitely take more than half an hour. So statement 2 is not enough information. So now let's put the two together to determine if we have enough information with both statements. So let's think about our estimated distance, our estimated speed, and then our actual distance and our actual speed. Okay, let's say that our actual distance, or I'm sorry, our estimated distance was 20 miles, and our estimated speed was 20 miles per hour. Okay, and then we can say, let's say our actual distance was 20. We were right on the nose, and our actual speed was 20. Again, right on the nose. How long would this have taken? Well, if we're traveling 20 miles per hour at a distance of 20 miles, it would take 1 hour. Okay, so this is a 1 hour time. However, what if we have an estimated distance of 20, an estimated speed of 20, but an actual distance of 20, same thing, but our actual speed was 10 miles per hour less. It was just 10. Okay? Well, then it's going to take us 2 hours. It's going to take us twice the amount of time. That is bigger than a half an hour gap. And so our answer is choice E, in that we don't have enough information to solve this problem. Okay? We need to know more specifics about how far the distance was and the time or the speed in which Joan was going. If x, y, and z are 3-digit positive integers, and if x equals y plus z, is the hundreds digit of x equal to the sum of the hundreds digit of y and z? Okay, so we have 3 digits, x, y, and z, and they are all 3-digit positive integers. So let's put in 3 placeholders for each of these, such that we have some a, b, and c, d, f, and g, some h, j, and k. Okay, and we want to know, is the hundreds digit of x, is a equal to the hundreds digit of y and z whenever summed together? Is a equal to d plus h? This is our question. Okay, the first statement tells us that the tens digit of x is equal to the sum of the tens digit of y and z. So this is telling me that b is equal to f plus j. And what else does this tell me? Well, I know that b must be between 0 and 9. And so this implies that f plus j is less than or equal to 9. And this is important because if f plus j was greater than 9, like let's say f was 6 and j was 7, that would sum to 13. And we would have a 1 that would carry over to our hundreds place. So since f plus j is going to be less than or equal to 9, we're not going to have a digit carried over to our hundreds place. Therefore, a will equal d plus h. So statement 1 is sufficient. It is enough information. What about statement 2? Statement 2 says the units digit of x is equal to the sum of the units digit of y and z. So similarly, we're going to have that c is equal to g plus k, such that c is between 0 and 9, and g plus k must be less than or equal to 9. However, there's a little bit of a difference here in that this is talking about the units digit. So while we don't have any 1 being carried over to our tens place, we don't know anything about our tens place values. Therefore, there could be a number that is carried over to our hundreds place whenever we sum our tens place digits. Therefore, statement 2 is not sufficient, so our answer here is A. Statement 1 alone is sufficient. If n is a positive integer, what is the tens digit of n? Okay, so we have another kind of similar problem here. We have n, and it says what's the tens digit. So we're just going to assume n has 2 place values. We'll call it a and b. And we want to know what is the tens digit of n. So statement 1 says that the hundreds digit of 10 times n is 6. Okay, well what would 10 times n be? Well, 10 times n would just equal a, b, and then this would be some 0. Okay, and we're told that the hundreds digit would be 6. So a must be 6. And if a is 6, then that means this a up here would be 6. And so we do know that the tens digit of n is 6. So this checks out. This statement 1 is sufficient. What about statement 2? Statement 2 says the tens digit of n plus 1 is 7. Okay, well, let's think of some numbers. What if n was equal to 69? Well, then n plus 1 would be 70. And we're told that the tens digit of n plus 1 is 7, so this checks out. But the tens digit of n is different. Or if n already equaled 70, then n plus 1 would equal 71. And here, the tens digit is 7. So we have a couple different possibilities for our tens digit with statement 2. Therefore, it is not sufficient. So our answer is again going to be answer choice A. Statement 1 alone is sufficient. If n is a positive integer and k equals 5.1 times 10 to the nth power, what is the value of k? All right, so statement 1 says that k is between 6,000 and 500,000. So if we know that k is equal to 5.1 times 10 to some nth power, then we can take 5.1 and let's have a trail of zeros. So if we move our decimal point over, that's like multiplying by 10 to some power. This would be 10 to the first power, 10 to the second power, 10 to the third power, and 10 to the fourth power. 10 to the fourth power would give us 51,000. 10 to the fifth power would be too much. That would be 510,000. And 10 to the third power would be too few, as it would be just 5,100. So here we can determine that n must equal 4 and k is 51,000. So statement 1 is sufficient. What about statement 2? Statement 2 says that k squared, here let me clean this up a little bit. Statement 2 tells us that k squared is equal to 2.601 times 10 to the 9th. All right, so we know that k squared is going to be equal to 2.601 billion. This will be billion. 10 to the 9th will give you a billion. All right, so in order to find k, all we would have to do is take the square root of both sides. So we know that k is equal to the square root of 2.601 billion. And we would be able to determine the value of k and then determine the value of n. So statement 2 is also sufficient. Again, remember that it's not so much that we have to find the actual answer, it's just important for us to determine if we have enough information to determine the answer. And in both statement 1 and 2, we have sufficient information. So our answer for this question will be answer choice D. Both statements independently give us enough information to solve the problem.